Hi folks, today we're going to model quite an interesting object, the Genelec Studio monitor. Take a look at its beautiful shape and those smooth flowing curves. This project will present quite a few topology challenges, especially when it comes to integrating openings while avoiding shading issues. We are also going to avoid using booleans. Instead, we will follow a subdivision surface modeling workflow, building the model by modifying the base shape, adding the necessary loop cuts, adjusting the topology manually, and inserting additional geometry with the knife tool where needed. So let's get started. I'll leave a link in the description below, a link to this model of Genelec. Our goal today is to model the front panel, solve the topology challenges. Here I've done a little sketch to decide some moments to prepare myself for this video. So we will solve the topology problems involved in integrating these loop cuts, establish the overall shape and proportions. And then in the next video, we will add the remaining details and create the textures. Let's begin. I'm going to hide my sketch for now. And I'll switch to the front view and import all the necessary blueprints. Here in the front view, and this is where I'll import all the necessary reference images and objects. If you happen to be looking at the scene from an angle like this, your references will be imported at the same angle, and that's not what we want. It makes modeling unnecessarily difficult and inefficient. There is no reason to make our lives harder, right? So we will stay in front view while importing everything. By the way, you will find all the required files in the description below this video. For example, the logo in SVG format will be included. The Genelec logo, we will need it later. Either in these these videos or later, we will convert that SVG into mesh. I will also include a link to this models page where you can download reference photos as well as the technical line drawings. Under the download section, you will find the blueprint we'll be using. Now let's analyze the shape. What primitive should we start with? A cube. Looking at the monitor, we can see that its shape gradually approaches a sphere. It bulges outward on the sides as well as on the top and bottom. What about the front and back panels? Are they convex? The front panel is fairly flat, while top and bottom, quite bulged, are much more pronounced. We can also see some nice clean bevels. Overall, the design has a very smooth sculptural quality. Ovals transition into squares, circles blend into ovals, and everything flows together in a very elegant way. Let's add a cube and let's get started. We have the dimensions on the blueprint, so let's rotate it first. I'm pressing R, Y minus 90. Let's check the dimensions. Including the stand, the height is almost 300 millimeters, 299 to be precise. We will start by using the overall dimensions, including the stand. Height 299 millimeters, width 189 millimeters, depth 178 millimeters. Now I want to determine the height of the monitor itself. To do this, I'll lower the opacity of the blueprint here. Move it so it sits in front of the cube. and scale it. Press S and keep scaling. Since we already know the total heights, including the stand, we can make scaling even easier by doing the following. Select the 3D cursor tool. Select the 3D cursor tool. And place the cursor here. Now please switch back to box select and now scale. Because the 3D cursor is currently set as a transform pivot point, we can scale relative to that point, which makes the process a bit easier. Great. That's set. Now I'd like to make the reference image unselectable while keeping it visible, since we will still need it later. Go to the restriction toggles, enable the cursor restriction and disable cursor interaction for the image. Now we cannot accidentally grab or move it. So now I'll select my cube. I want to separate this lower section. This will eventually become the stand. We could even model it as a separate object later, so for now I'll simply reduce the height of the cube. I'll enter edit mode, enable X-ray, select the bottom vertices through the mesh, press G and move them up roughly here using these protrusions at the reference. Now I'll add the primary loop cuts. The central loop cuts are the most important, so let's insert those first. We will need them very soon. Since we are still in X-ray mode, we can manually scale the shape like this. The only issue is that the 3D cursor is still located over here, while I'd rather have it back at the center of the scene. First, I'll press Shift-C to move it to this world origin. Second, I'll change the pivot point back to median point. Perfect. Now we continue. Press S, add necessary loop cuts. As always, we begin with the minimum number of loop cuts possible and gradually add more only when they are needed for additional details, such as these recessed areas. I think it's also a good time to switch to angle select, to edge select mode and a bevel to edge select mode. Actually, I'll simply add a bevel modifier. I'll also add a subdivision surface modifier as well. Notice that the bevel modifier should come first in the modifier stack. Now let's set the bevel segments to 12 for now. I leave X-ray mode since I don't need it anymore. Now let's compare our model to the blueprint. The shape isn't quite right yet, but we will fix that. So I'm back into X-ray mode, select these two edges, press S, let's adjust them. Now compare again. There is a noticeable difference here. Press S, refine this shape. This section also seems a little too high. Press G, Z, and move it down slightly. Perfect. Our primary shape is now established. We can also enable Shade Auto Smooth. For the subdivision surface modifier, let's increase the viewport level to 2. Again, remember that the bevel modifier should always stay above the subdivision modifier. Now I'll leave X-ray mode and inspect this shape. It matches the blueprint quite well. We also remember that the back has a slight convex curve. Actually, the bevel may be a little too sharp at the moment, so let's increase the segments slightly to 14. Let's create the rear bulge now. Switch to side view. Select these 4 faces. Enable proportional editing. Press G, Y, reduce the influence radius, and gently move the faces backward. Proportional editing gives us those nice smooth transition. The hotkey for it is O button. On the front, we observed that the surface is almost flat, with only a few slight bulge. So we will add just a subtle amount. Again, with proportional editing enabled, press G, Y, and move it forward slightly. Done. The top and side bulges are already there, but I'd like them to be a little smoother. I think it would be help to make the mesh more even. I'll press S, Y, 0 to straighten this loop. S, SY0 to straighten it. Select this edge. Shift Alt, select the entire loop. And press SY0 to flatten that loop. Now let's inspect this shape. Go back to front view. For the moment, I'll hide the blueprint. Let's rename it blueprint. Done. Now we can evaluate the shape without the reference in the way. It looks reasonably smooth, although I'll still refine these corners. I think I'll apply the bevel modifier now because I'd like to soften this sharp transition a little more. Let's soften it a bit without proportional editing and apply the bevel modifier in the object mode. Great. Let's examine the resulting topology. Now the fun begins. We are going to build this oval and this circular shape so we can integrate all the necessary openings. We can turn the blueprint back and continue adding loop cuts where needed. Let's add one here and move it into position. I'll select these faces, right-click LoopTools circle, scale it, scale along the x-axis, then along the z-axis, move it into place. The idea should be clear. We are trying to recreate this oval while solving the topology at the same time. I would also like to create a supporting loop around this area. I'm thinking about the best way to do it. For now, I'll hide the blueprint so it's easier to see. I think that we are missing here a supporting loop. It's important to have the supporting loops where needed. So I'll undo a few steps. Back to front view. Select these faces. Press I to create an inset. Turn the blueprint back on. Now use LoopTools, circle again, scale it on the x-axis. As a reminder, go to Edit Preferences, Add-ons to install, to enable this super useful LoopTools add-on, extension to be precise. Make sure it's enabled by checking the box. We have reached about 15 minutes for this lesson, so we will stop here.